All right, guys. So for today's science lesson, quick little science video. Cobra Kai represents first. Okay. We have what's called an energy pyramid. So in our lesson from last time, we talked about how our energy flows on a chart. Talked about how lion eats the squirrel. Energy from the squirrel goes to the lion. Squirrel eats the fruits, nuts, and berries. Energy from the fruits, nuts, and berries go to the squirrel. And then how those plants, those producers, get energy from sun, soil, water. So what we have next is what's called an energy pyramid. Sometimes we see it as a chart that's going from left to right. This one is going to be designed just like a pyramid. So I have my little brain pop video that we're going to do for it. So follow along. I'll pause on a couple of times just to talk a little bit. Let's go with it.
It's that time of year again, the time when fear leaves the ocean and heads into your living room. Nature's deadliest killing machines, as you've never seen them before. It's Shark Month, and this time, it's personal.
I love it.
I don't think you have anything to worry about. Some of that footage seems a little fake. Dear Tim and Moby, what is an energy pyramid? Your friend, Nicole.
All right. So this is our question. This is our goal to know what an energy pyramid is. So when we come back on to next week, I'm pretty much going to ask, what is an energy pyramid? And I hope that you paid attention to this video where you can actually tell me what an energy pyramid is. Continue.
I don't think she means that pyramid. The energy pyramid is a model for how energy spreads through an ecosystem. You remember food chains, right? Why are you being so literal today? Okay, the food chain describes how organisms in an ecosystem are linked together by what they eat. At the bottom are producers. On land, that includes plants from moss and grass to shrubs and trees. The producers are eaten by primary consumers. These are herbivores or plant eaters.
Okay. So we got producers, consumers. A new term for today is the primary consumer. So like he said, usually like the insects or the ones that just eat plants. We have the rabbit right there. They're mainly focused on eating plant life. We have herbivores, which we should already know. We should.
In turn, the primary consumers are eaten by secondary consumers. These are carnivores or meat eaters. This continues until you reach the animals at the top of the food chain, which have no natural enemies. Sharks are at the top of the marine food chain.
I want to believe that this really happens. It should.
Bears might be a better example here. Meanwhile, decomposers like bacteria and fungi break down dead animal and plant matter. This recycles nutrients back into the ecosystem. Food chains usually combine to form food webs made of many interconnected and overlapping chains. But let's back up for a sec and ask why animals eat in the first place. Well, yes, leaves, grasshoppers, and snakes are delicious in certain cultures, I guess.
Yeah.
But that's not it. Animals eat to gain energy. It all starts with producers. They create all of the usable energy in an ecosystem, and that's why they're called producers. Through the process of photosynthesis, they convert the sun's light energy into chemical energy, specifically a simple sugar called glucose. Glucose is the fuel that drives all living organisms. Plants use up most of the glucose they make to grow and reproduce, but they store a little bit of it in their bodies. So when a rabbit eats a plant, he's only getting a small fraction of the energy the plant got from the sun. The rabbit, in turn, uses up most of that energy to do things like breathe, keep warm, move around, and make baby rabbits. So if a fox comes along and eats that rabbit, he's only getting a teeny tiny fraction of the energy that was first absorbed by the plants. Get it? Right. All of the energy in an ecosystem ultimately comes from the sun. And since the amount of energy decreases as it travels up the food chain, it can be represented as a pyramid.
Now, I really like this design. It's still going with the arrows that we did the other day when we did our little design in our journals. Notice the arrows are still transferring what's happening with the energy, okay? Producers, I know, is a lot wider because there's a whole lot more of them, okay? There's a whole lot more plants. You need a lot of plants to survive. Then it goes to herbivores, which the width gets a little bit smaller. Carnivores, there's not as many carnivores. And then there's a top predator, which there's not as many around. There's only a few of them that roam a certain area. So the numbers, the width, and everything on there, because there's more producers definitely compared to top predators with that. Okay. So no matter what, the energy is still getting transferred from producers to herbivores. Energy is transferring from herbivores to carnivores and transferring to top predator. And you kind of got the cycle of things when you have the sun that goes with it.
In general, each level of the pyramid gets 10 times less energy than the level below it. So let's say you've got a square meter of forest. Every year, the plants growing in that little patch produce 10,000 calories. That's a unit of energy. Now, let's say herbivores consume those 10,000 calories.
There's a lot of them.
They burn 9,000 calories and store 1,000 in their bodies. So, for their predators, that square meter of forest produces only 1,000 calories of energy per year. That means there are going to be way fewer snakes and raccoons than rabbits and grasshoppers.
That
See where
sounds
this is
right.
going? Right. If the carnivores eat all of the primary consumers, they'll gain 1,000 calories of energy. They'll use up 900 calories and store 100 in their bodies. So, for the top predators, that square meter of forest only yields 100 calories per year. Oh, come on, sharks aren't part of the equation here. That's better. Anyway, since the bears and hawks have a fairly limited number of calories to live on, the ecosystem just can't support that many of them.
So that pretty much makes a lot of sense on things where there can only be a few, if any, more than one bear in a certain area. They're very territorial even with that because the amount of food that they need to take in pretty limited on things because they still have to hunt and it's not as easy as going to Burger King and getting the hamburger. So one reason why you don't see a whole bunch of flock of hawks running around, it's usually only a very small amount.
So, in most cases, as energy decreases up the food chain, so does biomass, the combined mass of all the organisms. A small meadow might support 10,000 grasshoppers, 100 snakes, and only 1 or 2 hawks. Great. Now let's get back to Shark Month. I think there's a special coming up about a shark who lent out money at a very high interest. Huh, who could that be? You know, there was something fishy about that guy.
Good pun. All right. That concludes our science lesson on for today with the energy pyramid. Do not have anything to do in our math in our science journals, which is nice. I almost said math journals, not today. Okay. So yes, very awesome. If you have any questions or anything, send me a message on there. Have a great weekend, guys. Go Cobra Kai. Show no mercy. Hitting the pause button. I don't know how. There you are, Cobra Kai.